All right, Panthers. This math maniac mindset, right? Math maniac. West side, east side, south side, north side? No, math side. Panthers. This is subtracting some fractions. This is some heavy, high level stuff. Okay. All right. Let's see what we can do with this. Let's first of all let's bring this in if we can. It's not going to let me right now. That's all right. Let's just roll. Oh yeah, 3 minus a half. I mean, you can do it kind of like, how do you do that? But you really got that. It's like 3 pizzas minus a half a pizza. You do 2.5 pizzas. And here we did symbolically 3 minus 5/12, which is almost like 3 minus a half. It's 5, 3. And if you have 12, 12 pieces inside of a pizza. And let's, if I can kind of just show this to you. 3 pizzas, right? And let's say this last one's cut up into 12 pieces. There's 4, 1, 2, 3, 4, 5, 6, 7, 8. How do you make it 12 pieces? Just pretend like there's 12 pieces here, okay? Because I can't think of it right now. But at any rate, let's get rid of 5 of those pieces. All right, so if you have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of pizza, and you give away 5. You give away 1, 2, 3, 4, 5. How many pieces of pizza do you have left? 1, 2, 3, 4, 5, 6, 7. 7 slices, 7 out of 12, 7 twelfths are left. Oh, what do you know? That's what we got here. 2 whole pizzas, 1, 2, and 7 twelfths. So what about this one? Same idea. I mean, you could think of this as, okay, if we have 5 pizzas, 1, 2, 3, 4, 5, and we cut one of them into ninths, again, pretend like they're all even. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you get rid of 4 of them. 1, 2, 3, 4. How many pieces of pizza does that leave you? 1, 2, 3, 4, 5 out of 9, 5 ninths. Okay, so but how many whole pizzas do you have? 1, 2, 3, 4. So this 5 becomes a 4, and what do you have left? 5 ninths, right? But if you were to kind of do this more symbolically without really necessarily thinking like, okay, this is what's really happening in the real world, you can do that too. You can just say, let's turn this 5 into a 4 and a 1, right? And that's really what we did. We have 4 here, right? And I'll color code this green. Here's our 4, green. And then we have 1. I'll color code that orange. Here's our 1. But we took the 1, and what do we do with it? We divide it into 12, 12. 12, no, ninths, sorry, just kidding, 9 ninths. 9 pieces of 9 pieces. So we have 4 plus the 9 ninths. Then we're going to subtract 4 of those pieces of pizza. So what we end up with is, we subtract here, what we end up with is 5 ninths. 4 ninths minus 5, so 9 ninths minus 4 ninths is 5 ninths. And we still have the 4 whole pizzas. And there's our answer. Just like we got it. See? 4 and 5 ninths. Okay, I teach. Ooh, how do you do this? This is so easy. Guys, it's just 3 and 1/4. So what is Mr. Hoffman trying to prove here? You'll see. How about this one? 3 and 1/4. Notice what I'm saying, 3 and 1/4? Yeah. You get where I'm going with this? 3 and 1/4. And I could write this as 3 plus 1/4. So you see where I'm going with this? Do you see where I'm going with this? Do you hear what I'm trying to tell you? So what I'm trying to say is there's a plus sign right here, right there. You guys got to, you don't see what I'm talking about? Right inside of there is a plus sign, but we don't write it down all the time is what I'm trying to tell you. See? That's the point I'm trying to make here. Okay? So how would you do this one? 5 and 6/7. Where's the plus sign? Right here. Do you see it? Right where I put that big green thing? Right there. There it is. Plus sign right in there. Okay? See it? We don't write it. There it is. You could write it though. It's important. This is a screenshot moment if you'd like. Do you really need a screenshot? You might. Okay. Okay, Mr. Hoffman, do or don't do. Why? What I'm trying to show you here is we're going to take this 3 plus 1/4. How did you do that, Mr. Hoffman? Because there's a plus sign right there. You see it? Abracadabra, poof, mathematicians that we are. And minus 11/12. See, I'm just kind of bringing this stuff down, brought the subtraction down, la la la. So now what do? Oh, we need to come up with, yeah, that whole common denominator thing, because right now we're looking at an apple and we're looking at an orange. And you're just going to turn this apple here into an orange. So you got to put it over 12. So 1/4 is the same thing as 3/12. How do you know? You can go 1/4 equals how many twelfths? Basically here, apple, so orange. And if you multiply, what do you multiply 4 by to get 12? 3. So multiply 1 by 3, and you get 3. Again, this is like multiplying this whole fraction by the number 1. 1/4 times 1 is 1/4, or 1/4 times 1, and this special one is 3/12. Okay, so here we go. We have an orange now. Now we could do this. Minus 11/12. Uh-oh, something funky is going on. Why did I put 3? Oh, I know why. Do you see why I put the plus sign here in between? Yeah, because we're going to have to borrow. Can you do 3/12? Oops, minus 11/12? No, this is like the whole pizza thing again. 3 pizzas, and then you have another pizza with just 3 slices out of 12. Again, pretend like, yeah, I'm just going to do this. 3 out of 12, right? But we're going to subtract 11 pieces. So if we were to do that with the picture, we could subtract 1, 2, 3. But now we got to start subtracting from this pizza right here, right? This pizza, which has how many pieces? 12. 1, 2, 3, 4, 5, 6, 7. Let's draw that better. Make them smaller to make them fit. 1, 2, 3, 4, 5. Come on, you can do this. 5, 6, 7, 8, 9, 10, 11, 12. So we took away 3, but we need to take away a total of 11. All right? Wait, why do I take away 3? Because that's all that's there. So we need a total of 11. So I got to count up to 11, taking away 11. I gave away 1, 2, 3 pieces. Now I'm giving away 4 pieces, 5, 6 pieces, 7 pieces, 8 pieces, 9 pieces, 10 pieces, 11 pieces. How many pieces do I have left in this pizza after I gave away a total of 11? 3 from this pizza. And how many from this pizza? 5. Wait, no. 10, 15? No. 9, 10, 11? No. 8. 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 3 is 11 total pieces I gave away. So how many are left in this pizza? 1, 2, 3, 4 pieces. So 4 out of what? 4 out of 12. So this is going to be 4 pieces out of 12 pieces left. We gave all the other ones away. So what do we have left? We have 2 whole pieces, 2 whole pieces, 1 whole piece, 2 whole pieces, and then in this pizza we just have 1, 2, 3, 4 pieces out of 12. The answer is 2 and 4/12. 1, 2, and 4/12 from here. But how would you do that without drawing pictures? Because sometimes you don't want to draw pictures. Maybe you're a symbolic math person. You want to do it that way. Maybe it's going to be easier, whatever reason you have. You borrow 1. You split this 3 into 2 and 1, right? Just like we did here. It's really the same as what we did in the picture. But on this one, we're going to make it a special kind of one. We're going to cut it up into 12 pieces. So that one's going to actually turn into a 12/12, right? So it's not there. Now it's 12/12. So what we have now is 2 plus 1, a special kind of one, a 12/12 kind of one, plus, oh yeah, the 3/12 minus the 11/12. So let's combine the 3/12 and the 12/12. When you do that, you get 15/12. So I'm going to rewrite that here as 15/12 because we just combined them, right? Come on, why is my eraser? Come on. Oh, it's pausing on me. Not responding. It needs a moment to process this. And it's just brilliant and genius math that I am demonstrating for you. Even the computer's like, wow, I need a moment to process this incredible Brilliant work Mr. Hoffman is demonstrating before us today. So you process too. What are we doing? We're combining the 12 twelfths and, oh, there it goes. The 12 twelfths and the 3 twelfths, right? Isn't that what we were doing? Yeah, we're combining 12 twelfths, and because there's really one, and the 3 twelfths, which is 15 twelfths. Now, we have these two pizzas here. Now we have 15 twelfths, and then a line is 11 twelfths. What's 15 minus 11? That's going to give you 3 12, wait, 4 twelfths. Oh yeah, look, remember, that's what we're looking for. So that's good that it's 4, not 3, right? 4 twelfths. And then we still have our 2, so 2 and 4 twelfths. Lowest common multiple, 4 and 12 is, oh, here, I guess I'm doing the problem here. It's 12. Is this another way to do it? Is this the same problem? Ah, big gosh, it is. All right, let's see what's going on here. Huh. Oh no, this is a different problem, I think. Oh no, 15 twelfths, 4 twelfths. Wow, this is symbolic. And I already did this and I forgot that I did it. It is from, a couple weeks ago. Oh yeah, now we could bring the 2 and 4 twelfths. We could simplify the 4 twelfths. Greatest common factor is, which would simplify? Greatest common factor or least common multiple? Oh, see, sometimes I even forget which one to use. So here's a least common multiple. Here's a greatest common factor. So it's either going to be 12, let's see, it's either going to be 4 or 12. So if we divide by, can you really divide 4 divided by 12? I mean, you can do 12 divided by 12 is 1. 4 divided, you can't really do that. So which one makes more sense is going to be the greatest common factor. Yeah, not least common multiple, because if we're going to simplify, yeah, this makes more sense because now you get 4 divided by 4 is 1, 12 divided by 4 is 3, so 1/3. So it'd be the answer in simplified form, 2 and 1/3. Here's a wonderful screenshot moment if you want. Do one together. You know what? I think we've done enough. So you try this one by yourself and we'll see how you did. Okay, this is how I got so far. See how you did something similar symbolically. I'm not going to draw pictures this time, I don't think. Although I do love them. They're so much fun. Okay, so let's see. 2/7 is an apple, 9/14. I'm turning both into oranges, which that's just my fun way of saying I need a common denominator. I make these both 14s. All right, this is already 14, stays the same. Okay, so now I'm like, wait, 4 14s minus 9 14s? I can't do that. I have to borrow. I'm going to borrow from my 5 over here. So if I turn my 5 into 4 and 1, I can borrow from one of those from the 5. See, this is total of 5 still. I'm going to borrow from this thing right here. The way I'm going to do that is I'm going to turn this one into 14ths to combine into this 4 14ths. So I'm going to say 14 14ths because that's the same thing as 1. So I still have my 4, and I have my plus the 4 14ths minus the 9 14ths. And I'm going to pause, and you see how you do. Come back. Okay, so I turn my 1 into 14 14ths, put them together right here, and I got 18 14ths right here. Oops, back it up. Don't cross it off. There you go. There we go. So I just want to show you something kind of neat here. I showed you this earlier. I'll just stick with this yellow for a second. Up here, let's rewrite this. 4 plus 18 14ths minus 9 14ths. It's the same thing. Remember that plus sign is 4 and 18 14ths minus 9 14ths. If that makes it easier for you to kind of visualize. So now you can just, okay, the 4 is going to still be there, 4. Now you can just do your 18 14ths minus your 9 14ths. right? Which is 9. 14ths. 9 minus 9 is 9. And then the 14ths. Ta-da! Dun, 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 dun. You do one. All right. Is this what you got so far? Okay, keep going. Keep going. Here's an example where you just do things without thinking. Mr. Hoffman didn't think that, oh, see this and this? They are not the same. Yeah, I mean, it's kind of like apples and oranges again. Call this an apple, call this one an orange. I didn't change them to common denominators before I did this. But I could do that now. um, let's see. You know what? Let's just, here, I'll show you. Let's just go with this. 4 and 1, 6. I'll be right back. Okay. I made another mistake. Did you catch it? I'm 100%. I did it on purpose. To see if you're paying attention. Yeah. Mr. Hoffman, what's 4 plus 1? It's not 4. It's supposed to be a 3. Oh my goodness. All right, keep going. All right. And just to keep things straight here, we're not doing this side anymore. We're just going right over here. So yes, now I got my 3 correct. Here, this 4 is a 3 and a 1. Okay, check your math. I just dropped down my two 12s, dropped down my 7 12s. Now I turn this one into a special kind of one, a 12 over 12 kind of one. And I'm going to combine my 12 over 12, my 12 pieces of pizza with my 2 pieces of pizza. That gives me 14 pieces of pizza, 14 12s. But I still have my 3 whole pizzas over here that I didn't even cut yet. Didn't even cut them into pieces. But now I got to give away pieces. I got to give away the whole kit and caboodle. I'm going to color code this red because this is what I'm giving away. I'm giving away 7 12s. So 7 12s here. So 14 12ths minus 7 12ths. So 14 pieces of pizza, give away 7 pieces of pizza. I will have 7 pizzas left out of this pizza, right? From all this pizza here. I still have 3 whole pizzas here. So what I'm left with is 3 whole pizzas, not even cut yet, and then left with 14 minus 7, which is 7 12ths. 7 pieces left, right? Because I get 14 minus 7 is 7 12ths. There's an answer. That's it. That's it for this one. Have a wonderful day.